Okay, practice slopes and equations of lines. Hopefully all of this is just review for you from algebra last year. But if not, let's go through some solutions. Number 2, we want to find the slope of the line that passes through the given points and then find the length of the line segment. So for finding the slope of this line, CD, passing through these points, we're just using the slope formula, which says you take the change in y's over the change in your x's. So this is x, this is x, this is y, this is y. So I take y minus y, so 7 minus a negative 8 over x minus x, so 0 minus 4. 7 minus a negative 8 gives me 7 plus 8, which is 15, over a negative 4. So I'm going to put that negative here in front of the fraction bar, and I get a total of negative 15/4. All right, for distance or length of the segment, we're just using our handy dandy distance formula, and that says we take our x values, subtract them, and then square them. We add that to our y values, subtracted, and then squared, and then at the very end we take the square root of both sides, or of the whole thing. So x minus x, we're using the same points. We do 0 minus 4, and then we're going to square it, plus y minus y, 7 minus a negative 8. Oops, excuse my dog there. Okay, so we do 7 minus a negative 8, and we're going to square that. Remember, the 7 minus a negative 8 becomes 7 plus 8. So I'm bringing it down. I have 0 minus 4 squared, which is negative 4. I'm going to square it. I'm going to add that to 7 plus 8, which is 15, and I'm going to square that. Bring it down. Negative 4 squared is not negative 16. It's negative 4 times negative 4, which is a positive 16, plus my 15 squared, which is 225. I'm going to figure out what 16 plus 225 is, and that's going to be 241. I'm just going to bring it on over here. So I'm trying to figure out what the square root of 241 equals. So in my calculator, the square root of 241 is approximately 15.5. That's rounding to the nearest tenths. All right, number 6. The only way that you can figure out, let me go up to the directions here, it says to decide whether the lines with the given equations are perpendicular, parallel, or neither. Remember, parallel is the same slope. Perpendicular is opposite reciprocal. And neither is there's no pattern between them. But in order to figure out what their slopes are, we have to have both of them set in the equation y equals mx plus b. So basically we're just manipulating our equation to solve for y. This one's already in the form y equals mx plus b. So for number 6 down here, we're going to solve this for y. My first step is to subtract x from both sides of my equation. So I get 2y equals 3 minus x. And then I'm going to divide everything in my equation by 2. So this all becomes y equals 3 halves minus, and that becomes 1/2 x, because remember we don't write the 1 in front of the x, but when it's a fraction we do. So my slope, I'm going to make this mx plus b form, so commutative property says I can just flip-flop these. So y equals negative 1/2 x, and this is a positive 3 halves. So my slope here is a negative 1/2. And negative 1/2 was the slope of my other line. And because these are equal, that means that these two lines are parallel, because the same slope means parallel lines. Okay, for number 8, it says name the slope of line AB in each of the given graphs and find the midpoint of AB as well. So my slope is my rise over run, or the change in my y's over the change in my x's. So from point A to point B, I'm just counting how does my y change, how does my x change. Well, my y values, I have to go up 1, 2, and my x values, I have to go over 1, 2, 3. And if you notice, it's going from left to right in the positive direction. It's going up. So this is a positive 2/3 slope. My midpoint formula, remember, is just x plus x divided by 2, y plus y divided by 2. So my x plus x divided by 2 is going to be 3 plus 0 divided by 2, which is 1.5. And my y plus y divided by 2 is 2 plus 0 divided by 2, which is just 2 over 2, which is 1. And you don't leave it like this. Midpoint is a coordinate point on a coordinate plane. So x value first and then y value. So it becomes my final answer 1.5 and 1. Alright, number 12 says to find the slope of the line perpendicular to this line passing through these points. So remember, perpendicular, I take my slope, and then in order to find its perpendicular line, I take the slope and I find its opposite reciprocal. So first I have to find the slope of this line. Well, slope formula, y minus y over x minus x. So that's going to be 2 minus 3 over 6 minus negative 6. And 2 minus 3 is negative 1. And 6 minus a negative 6 is 6 plus 6, which is 12. So that's the slope of this line in number 12. To find its perpendicular slope, I take this and I make it the opposite sign. So the opposite of a negative is a positive. And then I find the reciprocal, which means I flip the 1 over 12 and I make it 12 over 1. And we don't write fractions with 1 in the denominator, we just write it as 12. So I have a positive 12 slope perpendicular to my negative 1 over 12. Okay, number 14 might seem a little bit overwhelming, but let's just take it one step at a time. First step is to graph a line with a slope of negative 2/3 passing through points 0.20. So first thing is negative 2/3, it's negative. So from left to right, I'm going to go in the negative direction. And it's passing through the point 20. So that's my first thing. I know it passes through 20. So I'm going to go over 2 on the x-axis and 0 on the y-axis. From that point, it has a slope of negative 2/3. So that means I'm going 1, 2 y value, 3 x value. But remember, if it's going in the negative direction, I have to go this way 3 to get it to go in the negative direction, to get it to go down. So I just go 2, 0 and then slope 1, 2 over 1, 2, 3, 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 and I can go the opposite direction. 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Okay? So we're going to connect a straight line through those points. Let's see how this thing does on here. Connect a straight line through those points. Ooh, nice. Now, in order to get a perpendicular point to that point, start back at your 2, 0. And perpendicular is going to have the opposite slope and the reciprocal. So my 2/3, flip-flop it, becomes 3/2. So now I want, from this point 2, 0, I want a slope of 3/2. So I'm going to go up 3, 1, 2, 3, over 2, 1, 2. And I can go the opposite direction too. 1, 2, 3, 1, 2. And if you notice, from left to right, it would be going in the positive direction. That's a terrible line. That's why we're going to do this thing again. Let's see how that works. Ooh, not bad. So any point along 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, that's a point that's going to be perpendicular to this line that we graphed.